In a previous video, we learned how to find OR probabilities, that being a situation where you wanted one thing or the other to happen, which basically meant we wanted at least one of them to occur. And all we did there was we added the probabilities together. In this video, we're going to talk about AND probability. So if I want this and that to happen, that means that both of them need to happen. So underneath where it says AND right here, just write down for yourself that means both have to occur. So you're going to have two things that are going on at the same time, or more, depending on the problem. Before we get into that, though, we need to introduce a vocab word, which is independent events. And I kind of wrapped the definition up in here in my little sentence. Two events are considered independent if one of the events occurring doesn't affect the probability of the other. In other words, one thing happening shouldn't change the probability of the second thing happening. If it does, then you say they're not independent, or they're dependent. So, this is easiest seen through a few examples here. So I wrote down three events, and all we're going to do here is decide if these events are independent or if they are dependent. First thing we're going to do for number one is flip a coin, and then we're going to roll a number cube, which is just a fancy way of saying rolling a die. Now, whatever happens on the coin, it's not going to have any sort of impact whatsoever on what happens on the dice. So we would say these two events are independent. The coin does not affect the number cube at all. They're totally separate events going on. On the second one here, we're going to draw a card out of a deck. So standard deck of 52 cards. We're going to shuffle them up. We're going to draw a card, put it back, and then draw a second card. If we put the card back, every card has a 1 out of 52 chance of being picked on the first one. And when we put it back, there's still a 1 out of 52 chance of every card on the second one. So these are independent events because we put the card back. What happens on the first draw has no impact on the second one. So now that we've seen a few examples of things that are independent, you may wonder what wouldn't be independent, or what would be dependent, in other words. This last one here is a very similarly worded problem. We're going to draw two cards, but this time we are going to do it without replacement. Without replacement means you don't put the card back. So I'm going to shuffle up my deck of cards here. I'm going to pick a card, put it down on the table here, and I'm going to go and pick another card while that card is still right there. So on the first card I'm picking right here, there's a 1 out of 52 chance for all of them. But then I took one of the cards and sat it down right here. When I go back for my next card, all the cards that are still in the deck here have a 1 out of 51 chance of being picked there. The probability changed from 1 out of 52 to 1 out of 51. That makes this dependent because the first one affects the probability of the second. Another way of thinking about it, say I got the ace of spades in my first pick. I can't pick the ace of spades again, so that probability went to 0 for the second choice. So, keywords here that you'll want to watch out for: without replacement is a tip-off that it's going to be dependent. Replacement, or with replacement, is usually independent. Now that we have this vocab down, we can start to solve basic probability questions involving the word AND. And I have a little formula for you guys here that assumes the events are independent. So if A and B are two things that are going on and they're independent, all you're going to do to find the probability of A and B is take the separate probabilities and multiply them together. So just like we added with OR, with AND you are going to multiply your probabilities. So that is actually worth writing down as like a little box with a star next to it, because kids will forget this. If you can keep this straight, you should be in really good shape with probability. When you see OR, you are going to be adding your probabilities. When you see AND, you are going to be multiplying. So for our next example here, we want to look at the situation where you roll a dice, then you roll a second die. So you're going to roll one, you're going to see what you get, and you're going to roll a second one. These events are independent because what happens on the first dice has no impact on the second. So this formula that we learned just now is going to apply to this problem. So in this first example, we want to get a 5, and then we want to get a 4. Even though the word AND isn't explicitly written right there, it's implied when you say then. That means you want to see the 5, and then you want to see the 4. You need both of those things to happen. So all we're going to do is multiply the separate probabilities together. The probability of getting a 5 on a die is 1 out of 6, times the probability of getting a 4 is also 1 out of 6, giving us an answer of 1 over 36 for this problem right here. Because when you multiply fractions, you multiply the top numbers, you multiply the bottom numbers. For our second one right here, we want to find the probability you get an even number, and then you get a 6. So an even number, there are 3 out of 6 numbers on the dice that are even, followed by a 1 out of 6 chance of getting a 6. Now you could have also made this 3 over 6 1/2. That was the same thing. When you multiply straight across, though, you get 3 over 36, which is going to be 1 over 12 for this problem right here, for our probability. Our next one here, it says the probability that both are 3s. Again, it doesn't explicitly say the word "and" in it, but if you want both to be 3s, you want to have a 3, and you want to have another 3. So we need to take our separate probabilities, and this is actually very similar to number 1. And this section is just 1 over 36. Probability of 3 for each one, you multiply them together. For our last one, we want to get a 7, then we want to get a number that's less than 5. So for probability of 7, there's no 7 on the dice. So that's going to be a 0 out of 6 chance for that happening. Less than 5 means 1 through 4, so we have a 4 out of 6 chance for that. When you multiply straight across, you get 0 over 36, which just equals 0. And that makes sense because, okay, if you want both of these things to happen, that's never going to occur because you can't get the 7 in the first place. This takes us to our final example here of the video, which is looking at a situation where you would flip 4 coins in a row. We want to find the probability that all 4 of those coins will land on heads. So even though they didn't explicitly say here, if they're all landing on heads, that means what we really want is heads, and heads, and heads, and heads. We want all of them to land on H. That means you need this one, and this one, and this one, and that one. So all we do is take our 1/2 times 1/2 times 1/2 times 1/2, because probability of each coin landing on heads is 1 over 2. And we end up with 1 out of 16. So there's a 1 in 16 chance that if you flip 4 coins, they will all land on heads.